Good morning. Today we will discuss the unit number 4, that is design flexural members. Okay, so actually flexural members means the beam. So in fourth unit we will discuss the beam design. So in that we will discuss the design about the simply supported beam, then continuous beam and the cantilever beam. Okay, so in simply supported beam, continuous beam and cantilever beam we will discuss singly, doubly and flange beam. Okay, so before start the design we will discuss some basic points regarding the design of beam. So first is the basic rules for the design of beams. First, effective span. So effective span we already discussed in slab, that is unit number 2, and some explanations regarding the effective span is given in clause number 22.2, page number 34 of IS 456. You will see here I have given the clause number here, so we can refer this IS code and clause. After that, effective depth. Once you calculate the overall depth, then you can calculate the effective depth by considering the d minus effective cover, or the another formula to calculate the effective depth is d minus cover, clear cover, minus 5/2. Okay, and if the ratio of overall depth to width should be lies between 1.5 to 2 meter, while you are calculating the dimension of the beam, so we required width and depth of the beam. Once you calculate the depth, then you can calculate width by considering 1.5 to 2 ratio. Then controller deflections, already we have discussed this controller deflection in slab designing. Okay, and the clause is given as 23.2, page number 37 of IS 456 2000, unit 1, part C. After that, the reinforcement. So we have discussed the minimum reinforcement and maximum reinforcement required in slab as per the IS code, but now here we are designing the beam, so we should discuss some minimum reinforcement in tension side and minimum reinforcement in compression side, as well as the maximum reinforcement. So criteria for the minimum reinforcement in tension side is given in IS, that is clause 26.5.1.1, page number 46, and the minimum area of tension reinforcement shall not be less than that of given following formula. So whatever reinforcement you have calculated, main reinforcement you have calculated for the main beam, so that main reinforcement you should compare with this formula, so it should not, or calculated area of steel should not be less than of this area of steel. Okay, then after that, the maximum reinforcement, the criteria for maximum reinforcement is also given on page number 47. So it shows that the maximum area of tension reinforcement shall not be exceed 0.04 b into d, means cross sectional dimensions. After the compression reinforcement is also given, compression reinforcement is also same as a 4. Actually given in 456, page number 47.04 BD. Side face reinforcement criteria is also given on page number 47. You can read it thoroughly by using this IS code. Then transfer reinforcement criteria is also given on page number 47. Maximum spacing of shear reinforcement criteria is also given, that is 0.75 due to 300. Okay, so read it thoroughly by using IS 456. The total theoretical explanation is given over here. You can see the spacing of reinforcement is also given here. The diameter of bar, if the bar are not the same diameter of the larger bar if bars are unequal, 5 mm more than nominal size of coarse aggregate. Okay, these are the criteria to provide the some minimum, maximum spacing or number of bars. Then nominal cover to reinforcement is also given on page number 47. Nominal cover to meet durability requirements. Okay, so total basic criteria is given here. Curtailment of tension reinforcement, this criteria is also given. Actually here we have derived one formula to calculate the curtailment of reinforcement. Basically what is meant by curtailment? If you see the bending moment of simply supported beam, so the bending moment of simply supported beam, the bending moment at end supports 0 and at mid is maximum, and we are calculating the reinforcement by considering the maximum bending moment. So whatever reinforcement we have calculated by considering maximum bending moment, it is not required at the support. So for that conditions we should curtail the some reinforcement to achieve some economy. So curtailment here we have calculated. Actually here I have considered the one formula, that is AST is directly proportional to bending moment. Means whatever reinforcement you are calculating is directly depend on the bending moment. One formula is given in book, that is if we consider the one axis, x-axis, and the x is the distance from the central axis or center axis of the beam, that is L by 2 under root nx by nc, where nc is number of bars at the center and nx is the number of bars which can be curtailed at section xx. Means in that case you should consider the how many number of bars you want to curtail, and according to that you have to calculate the distance of the curtailment from the center of beam. Okay, this is a simplified curtailment rules for the tension reinforcement in beam as per SP34. So SP34 has given reinforcement detailing of cantilever beam and simply supported beam. How you consider the distance of curtailment bar from the supports, then load transfers on beam. Basically here we have designed the slab, and we know that the total load on the slab which will transfer to the beam. So while designing the beam, first we should calculate the total load acting on beam which will come from the slab. So some basic points are given here. So first criteria is load on beam supported by one-way slab. Means if you are designing the beam and that beam is subjected to a one-way simply supported one-way slab. So for that one-way slab you should consider only rectangular portion. So this shaded portion is shows the rectangular portion. Okay, this rectangular portion. So this rectangular portion is considered to design or to transfer the load from slab to beam. Now here we are calculating the load transfer from slab to B1, B to beam. Okay, so here the load transfer from slab to beam B1 and B3 ends or current beam, that is W into Lx by 2. Means load on this B1 and B3 beam is W into Lx1 by 2, means distance by 2, and while calculating the load transfers to B to beam means central beam, so that load is W into Lx by 2 plus Lx by 2. Okay, similarly you can calculate the load transfer on beam supporting two-way slab. Okay, so first for transferring load from two-way slab to beam, so first we should draw this triangular and trapezoidal diagram. Here we can see in shorter span the triangular load will transfer to the beam, and in longer span the trapezoidal load is transferred to the beam. Okay, so a direct formula is given here, so you can refer this formula to calculate the load coming on beam from the slab. Long edge equivalent UDL from the bending moment, this formula is usable for us, that is WLx by 2 1 minus 1 divided by 3 beta square, and for short edge WLx by 3. You can use this formula. Then after that we will discuss in next video design steps simply supported and cantilever singly reinforced beam.